Hi, I'm Walt Boyes, editor of the Grantville Gazette and chief editor of Ring of Fire Press, and I want to welcome you to Weird Tech and Chocolate, a memorial for Rick Boatwright, Kevin and Karen Evans. I'm sorry I'm not here in person, but stuff happens. Kevin Evans passed just before Christmas last year. His wife Karen followed him in March. They were so tied together that nobody was very surprised. Rick passed in July. James Richard Rick Boatwright Jr. passed on July 22nd, 2021 due to complications from pancreatic cancer. He was 66 years old. Rick started his career as a chemistry teacher at Topeka High School and then moved on to launch a computer hardware and software company, TBC Software and Voxshop Solutions Groups, where he spent his entire career serving customers in a business vertical he helped create, serving the computer needs of vocational workshops around the country. Rick's naturally curious nature and his interest in science and technology fueled a lifelong passion for science fiction and fantasy. In his mid-40s, Rick found tremendous satisfaction working with acclaimed New York Times best-selling alternate history science fiction author Eric Flint, and went on to be a contributing author in many works within Flint's Ring of Fire universe. Rick was a mainstay of the 1632 project from the very beginning. He was, as he often said, the head geek, and was responsible for everything tech that went into the 1632 universe, from taking care of Eric's own computers, to managing the website, to being on the editorial board, to doing the weird tech panels, and to creating characters and writing stories. With Karen Offord, he created Dr. Philip Theophrastus Gribbleflots. But sometimes he'd find his own characters in real downtimers. Rick's first full-length book, 1636, The Chronicles of Dr. Gribbleflots, co-written with Karen Offord, was published in 2016 by Baen. Working with the authors and publishers at Baen was the realization of a lifelong dream for Rick, and he never took those opportunities for granted. Unfortunately, Rick never saw the published version of his second Dr. Gribbleflots book, Dr. Gribbleflots and the Soul of Stoner, which was published in September. But before we lost Rick, we first lost Kevin Evans. Kevin had retired twice from the FAA in Albuquerque, where he kept the electricity running for the route control center that kept airplanes flying safely. His great desire was to homestead on his own land in Idaho. Using a travel trailer and recycled shipping containers, he was well on his way to being the mountain man of his dreams when he went outside in bitter cold in late December 2020 to check on an electrical failure, and apparently had a heart attack and died. His wife, Karen Carnahan Evans, found him the next morning. Karen followed him in April 2021, dying of cancer. They were so close that nobody was really surprised.
You know, when I go fighting in the SCA now, I stand in the back with my crossbow and shoot people in the face.
Well, welcome to the 1632 Minicon. I'm Walt Boyes. I'm the editor of the Gazette. And the first thing we're going to do is our traditional Weird Tech panel for the next few hours. Rick Boatwright and Kevin Evans and I will be talking about the different paths that technology has taken in the 1632 universe. Some real weird paths.
Right.
Rick?
Thank you. So, I'm turning this session around from my traditional order because I always run out of time to do something that I want to do at the end. So I'm going to do the end first. So, there is a reality that all of us that are involved with technology face and always have, that Murphy's Law plagues us. And there's no way to avoid it. It's simply part of the way the universe is built. Another science fiction author Christopher Stashif, in his Wizard series, the Grammy series, had an absolutely wonderful way of describing it. He said that Murphy's imps of the perverse express the perversity of the universe. And boy, is that true. And so, one of the characters in the 1632 series had read Chris's books and was enamored of them and wanted to, and loved the idea of a talisman that the technologists would use against Murphy's imps to help them be reminded to keep Murphy in front of them. You can say, get thee behind me, say, Murphy, you've got to keep in front of you. You've got to keep your eye on it. And so the talisman that he chose was the exact same as Chris Stashif's talisman, the little yellow pocket screwdriver, which reminds you of that. Now, Chris, in his stories, had this be the symbol of the order of the church devoted to Saint Vidicon of the Capitol, one of his characters. Father Nick thought that would be a good idea, but Larry Mazzari in the 1632 series said no, that he was not going to allow him to start an order, a Catholic order, devoted to a fictional saint created by an unchurched Episcopalian. So, and not only that, but it was the wrong saint anyway, because the right saint had been sainted in 1596 and was, in fact, and still is, the patron saint of joy, the patron saint of buffoonery, and the patron saint of fools. This seems entirely appropriate for those of us involved in technology. Not only that, but his name is Saint Philip. So it's entirely appropriate to have as our talisman against Murphy, Saint Philip's screwdriver. Okay, fine. Normally I would laugh, but normally I have a bigger audience. So anyway, so I have for you today, as your souvenir from visiting 1632, visiting the Ring of Fire, if you don't already have one, you have your very own St. Philip's screwdriver. So there you go. And would you just pass those along if you wouldn't mind terribly? Thank you. I have a
no way until the 1640s or 1650s that we would get even very low integration on transistors, tubes, and integrated circuits. It just wasn't going to happen. So all the computers that came back with Granville,
the 1999 circa computers were it. And when they all died, that was it. And they will. There probably aren't any more working after about, what, 1637, 1640, something like that.
Maybe 50 maybe, for some that are super carefully controlled.
But that's it. So what do you do? Well, I remembered that there is a fluidic technology called the Coanda effect, which also underlies the ramjet and a number of other things. Coanda was a Romanian physicist, and he developed the concept that if you push a fluid, whether it's air or a gas or water, against a bluff body, that fluid has a 50-50 chance of going either this way or this way. It's random. It will go one way or the other. Then it was discovered that you could make a feedback loop so that if the fluid was going this way, it fed back around and injected into the fluid stream here, which would make the fluid flop to the other side of the bluff body, where you would have a feedback from that side, which would make it flop to the other side. Binary flop switch.
So the bottom says,
Yeah. You have a power stream, a control jet, and the output. And what you do, basically, what that makes is a binary flop switch, like a fluidic transistor. It is, in fact, a fluidic transistor. This has been used for all kinds of things, including there was a company for a number of years that made a cold water meter that installed outside your house this way because it doesn't require a great deal of power to operate. And it's very highly accurate because this produces a pressure change here. And you sense that pressure change as a pulse. The faster the pulse, what that means is that the fluid running through the device is operating at a higher velocity. It's really cool. This is neat stuff. So we can make a two-state device on-off. We can make
ones and zeros.
basically ones and zeros. So we came up with the idea of producing a fluidic computer, which we call the oscillator. And it operates by taking a whole bunch of these critters and sandwiching them, because you can make these things, you can make them out of clay, poured with slip and molds, and stack them dozens and dozens of them high. So what you've got is a whole bunch of fluidic transistors. Why did this not get used in the original timeline?
We didn't think of it.
No, that's not true. We did think of it. There were a lot of people making fluidic computers, fluidic amplifiers here. Yeah.
Because it got wiped out by the integrated circuit.
Exactly.
Because I remember in 1964-65 at the World's Fair, National Cash Register, NCR, had a fluidic cash register that they were downloading from their pavilions.
Yep.
Absolutely.
That's the concept that we came up with for the oscillator. And the oscillator will be used for a while in the 1630s until it becomes possible to make tube-based computers or transistors or a combination of all the same. But this is a classic example of weird tech. It's going to be used in the 1632 universe because we can do it. And we can do it a whole lot faster than we can do integrated circuits. And nobody's going to sit around and wait for integrated circuits to happen. They need computing now. They need cash registers now. They need adding machines now. They need they need the ability to do small computation runs now.
Yeah, the problem with this also is the Linux, it doesn't work anywhere near as fast. as
That's right.
solid-state logic.
That's right.
1/1000th the speed. A water-based fluidic system can operate at best at about 1500 hertz, where a crappy personal computer from the 1970s, like an Apple II or a Tandy Radio Shack TRS-80, operated at 1,000,000 hertz. So it's 1,000 times slower. On the other hand, it's 15,000 times faster than a room full of people with pens and sheets of paper.
And about that same amount faster than a room full of people with abacuses. Abacus on it, however you say it. The point is,
It's English. S's make work. Abacuses.
abacuses. Anyway, the point is, why would we use it? Because it works. Because we can use it now. And because people need that stuff now. Yeah, exactly.
Yeah, and Chuck Gannon will be mentioning that the next Commander Cantrell stories, which feature land-based shore batteries and an oscillator to trajectory ballistic calculations, which was in fact the second thing we used computers for ever. But casualty analysis and ballistics, that's what we used computers for in World War II. And so Commander Cantrell's next story will be featuring surprising results of using an oscillator.
Can I just borrow you for a second?
Huh? Yes. Oh, sure. Here.
Yeah.
Seems to me there's one other control logic in electromechanical devices.
Sure.
Basic interpret, really mechanical parts. Very simple equipment, 3 or 4 moving parts, and one of them things to make it work.
Sure. This means too that now one of the things that I was talking earlier about a friend of mine who passed away last October, a guy by the name of Dick Morley. How many of you know who Dick Morley was? Shame on you. You all should know who Dick Morley was. He invented the floppy disk. He invented anti-lock braking. He invented the programmable logic controller, PLC, which every factory runs on. He invented the people mover algorithm and about 150 other great inventions from the 20th century. He invented zone-based building, heating, and air conditioning. He was a great inventor. In order to you cannot manufacture anything in bulk today without using Dick's invention of PLC. Now, we think that maybe 2 or 3 programmable controllers came back with brand new. They were probably part of the stuff in the coal mine.
As many as 3 perhaps.
Maybe 3. Which means that, and the PLC is the basis for CNC controls, milling equipment, and things like that. There are some CNC machines that have PLCs on them.
And the power plant.
And the power plant has some too. So maybe it doesn't. Totally. If you're ramping up to try to get to as close to early 20th century manufacturing as you can get, you need a form of programmable controlling device. Because the PLC was invented because GM's Saginaw Gear division couldn't afford to retool every year because that meant they would have to take hundreds of thousands of relays down and rewire them all, and it would take 3 months to retool Saginaw Gear. The programmable controller allowed them to do it in a week and a half. Okay?
And with the oscillator, you ask, some people always, inevitably someone asks the question, well, why don't you use relays? Make relay-based computers, because relays are by state, right? You have feedback loops. People have, in fact, built relay computers. Conrad Zuse in Germany had a company that built them. Here's the answer, okay? And certainly we can make relays using telegraph. So relays are easy. Why didn't we use relay-based computers? Remember his comment about the slowness of the fluid computers? The fastest relay-based computers that anyone has built, including ones built since 2000 as demonstrators, they have managed to make operate at 6 hertz. 6.
Which is below audible frequency. So it doesn't move.
So, every so often, we, in the Weird Tech panels, reminded people that there's a big difference between the 1632 universe and steampunk. The difference is that our Weird Tech actually works. Kevin was a warrior. So was Karen. After leaving the military, Kevin and Karen found the Clash of Combat in the Society for Creative Anachronism, where he was known as Sir Thorgeir the Viking, and she was his faithful squire, Lady Tirka. Karen spoke fluent Portuguese, having done her mission work in Brazil. She learned about chocolate there and wrote stories for the Gazette about bringing chocolate to Grantville. Beginning in 2000, Kevin and Karen wrote together as a team, just as they had fought together as a team in SCA. Their stories, No Ship for Tranquebar and Tales from the Mermaid and Tiger, Engines of Change, are seminal stories that directed the development of airships and steam engines. Fire on the Rio Grande told the story of the revolt of the southwestern Native Americans, the first American Revolution.
Kevin is our firearms person, among other things. And if this were a free state, among other things, and not New York or New Jersey, then Kevin would have brought with him the AK-4 rifle from the Russian novels that Gorgon wrote. But sadly, this being not a free state, we don't have it to show you. But we can talk about it. What we have, I'm sorry to say, is the bayonet. Okay? But nevertheless, we're going to talk about it for just a minute, because remember that Weird Tech has to work, and people thought that the rage-loving black powder weapons that we were making, that we invented for Gordon Paula for the Russian novels, were ridiculous and we possibly work. So were ridiculous. He made them. So I'll show. He shoots things with it. Yeah.
Yeah, it's okay. It's not a muzzle stuffing black powder.
Yeah.
It's got a lever on the side. Pull the lever back, turn it over, chamber falls out, put loaded chamber in, put the cap on it, turn it over, chamber falls out, put the lever forward and fire. We got 12 rounds a minute out of it. When we were at Marcon, we put it on the table and we swapped chambers as fast as we could. So you figure you got a platoon of 12 guys with these things. They come up, you designate 2 people as loader, you take all the chambers and hand it to them. They come on their job.
As the chambers fall out of shot.
They take all the chambers and hand it to them. So they load the chambers as rapidly as possible. And they increases the rate of fire of the infantry platoon or a squad, just enormous rate of fire. Plus you can reload it while you're laying down. To a squad, just enormous.
If I recall correctly, the standard for musketry in the British Army during the Napoleonic era was a well-trained musketeer could do 4 rounds a minute.
That's the extreme upper edge.
Extreme
Three
upper
was
edge.
three was the general training target.
Years ago, my wife and I went to the recreation of Battle of Waterloo on its anniversary, 175th year. We were at Waterloo, and they had 3 full English musket squares. Not in 64 they had then, but it was pretty impressive to watch the fire come down.
But imagine instead 12 rounds a minute. And the ability to do that instead.
Undercover.
12 rounds. And then, instead of being muskets, this is a rifle. And so instead of being smoothbore. So how big a group at 50 yards?
At 50 yards, I'm holding about a 2-inch group. And that's changing the chambers out, which means I have to reacquire the target every single time. That's changing the chambers.
Yeah.
I have to reacquire the target.
A chamber is a piece of steel about like that and square, right? So it's a piece of steel about like that, and it's got a hole drilled, a blind hole drilled down from the front, and it's got a primer cap from the on top, whatever you're using, and it's shaped. It's got angles cut on it, so that you can't put it in backwards.
Yeah, putting it upside down.
Right. So a chamber is a piece of steel that weighs about a pound. So 2 pounds. So I want you to imagine a Russian Cossack wearing a bandolier of 2-pound chambers.
And what's going to happen then? We're immediately going to go to the lowest point.
Well, yeah, but still, you know these guys are going to do it.
Yeah, but imagine that the close
Okay, when you run out of powder and shot, you just put them all in a bag and go clotting people with it. Because 15 pounds steel.
We also imagine Cossack soldiers playing an interesting form of a combination of dice and Russian roulette.
Because you put a loaded chamber with a cap on it, you roll across the ground and see who it shoots.
Right. So anyway, but as a result, and by the way, we've all yelled at Kevin because he put this extremely long barrel on the thing. And it weighs, yes, I know you like it, and it weighs a ton.
Weighs 23 pounds.
And it weighs,
Weighs 23 pounds.
It weighs 23 pounds. It's fine to shoot prone. It really is. It's a gorgeous rifle. It's fine to shoot prone. Shooting it standing up, I will never try again. It's just not a thing. I will never try.
Yeah, the Cossacks
I just know. Fine. Shooting it prone, fine. Standing up, no.
I put a bipod.
We're going to make him build a shorter one.
It kicks like a
My
mule,
instructions
too.
were the first thing that I want you to do on the next one is cut off a foot.
Well, I'm taking 14 inches.
First thing that I want you to do on the next one is cut off a foot.
But no, so the whole concept is this stuff has to be made. And you know, you've got 3 or 4 shops come back through the ring of fire. You've got some really competent machinists. They're training new ones as rapidly as possible. And the other concept is that anything that you can get work will be used until it's just nothing fragments. Any aircraft that can stagger into the air is going to have a market until it's just literally unusable. So the big deal with firearms is there's nothing that they can't do that we're doing now. All they've got to do is push it out. When you're hand making this stuff, all they've got to do is it takes long. You're not going to get as many as hand making this stuff. I do steam engines. My steam engine is weeks, if not days, away from the first firearm since 1956. And she's a little feller. She's 500 tons. 122 feet long, goes 110 miles an hour. Had 2 onboard computers in 122 feet long, 110 miles. Yeah, 42 onboard computers. And so I do steam. And steam is incredibly dangerous. And
You say 2 onboard
steam is incredibly dangerous. No, I'm talking about the automatic train stop, the ATS, and the water level and fire control computer. It's both analog and the 1940 fire control computer.
Yeah, don't forget analog computers were used for a long time and they still work.
Don't forget analog computers.
And how many of you read James Blake's book on chaos physics? Any of you read that? He talks in there about an analog computer that the guys who dropped out of UC Santa Cruz and came up with chaos theory used. And I'm here to deny that I ever gave them the key to the Natural Sciences Lab where that computer was stored.
There's also the Mississippi River Basin analog recreation computer that the U.S. government used still operates.
No, not anymore. They closed it a couple of years ago.
Oh well.
Yeah, the Vicksburg thing is completely gone now. It's just a shell. I know.
So cool. Anyway, so that's his big steam engine. His little steam engine, which you told me is about ready to be little steam engine.
I built a V6. Oh, my little truck. Yeah, that's designed. I've got a Dodge D50 pickup. The engine in that thing was the first engine the Japanese made for the American market. It's extremely complicated. It has 18 idler arms on it. It's on the timing shape for a 4-cylinder engine. It's just, they only built it 2 years. You can't get parts. I'm going to pull the engine. I'm going to put a 3-cylinder steam engine in it with a Yarrow steam generator and have a steam powered truck. Because I want a steam powered truck. I don't care about it.
And so, and so he mentioned the concept, he mentioned something called the steam generator. He's not going to employ it, the steam generator. Here's the interesting thing. Turns out, the big engine, traction engine, locomotive, boilers, the big engine, but boilers are dangerous because they have many gallons of high pressure steam and water at extremely high pressures. And here's the problem. If you have water at extremely high pressure and high temperature, so that if it breaks open and the water flashes at high temperature,
a gallon
of water turns into 3,600 gallons of steam at room temperature. So that means 1 gallon of water sitting over there that was superheated, and somebody opens up the lid. It's going to kill all of us. Not because we'll be burned. That much steam will fill the room, but it's not going to burn you. That's not the issue. What will happen is it will force out every single piece of oxygen in the room.
You'll get about 3 paces in your arm.
Yeah, right. And steam kills people both because of the physical explosions and because of burns and things like that. But look who's here. But the thing that kills people the most with steam is oxygen deprivation, which is pretty weird. Steam is super dangerous.
In 95, which is pretty weird. Tour ride operator in 95 had a steam explosion, and it killed 3 out of the 4 people in the cab. And the wind was blowing the right way, and they hit 3 out of the 4 people passengers over the train. And the wind was blowing the right way. That created a new set of law for steam. It was actually nicer to us. That created a new set of law because we are now allowed to dwell on boilers.
So as a result, there's this alternate technology for boilers, steam generators, which use coils of pipe and complex counterflow pumping and flames in the right direction. But the point is that at any given moment, the steam generator for a truck or the steam generator for whatever has
Less than a gallon.
a couple of pints of water in it at a time, and so it doesn't explode like, you might get a pipe failure, but it isn't going to go which is really cool. Steam generators have been used even at large industrial scale. The
Top end's about 1,000 horsepower.
well, or lots of steam engines like the Germans used in the battleship Bismarck. So the Bismarck didn't have boilers. Bismarck had
Steam generator.
steam generators, a lot of them, but you get about 1,000 horsepower tops out of one steam generator.
The thing they're used for modernly is they're still in use for peaking generators. In other words, when the grid power demand goes up and you need a sudden spike of power, these things ramp up in operation in less than 10 years.
And in the 1950s, Ford experimented with steam generators and steam-powered cars, and they developed a car which could go from frozen, setting outside here, or actually at colder temps, frozen solid, to running as a steam engine in turn the switch and be driving down the road in under 3 minutes. Yeah. No, they
No,
used
he had a
a boiler.
boiler. It was a nice boiler, but it could wire around really nice.
No, they used a boiler.
But Stanley steamers had a tendency to burn wire rounds off and isolating.
It's a boiler.
Yeah, watch one of Jay Leno's Stanley steamer vids. He always shows that.
Yeah, it's a boiler.
One of the things that is interesting in the history of technology is that the history of safety, the history of industrial safety, comes from boiler safety.
And every annoying rule that you've encountered that, you kind of go, what a big pain that they make you jump through that hoop. Almost every one of those hoops is the result of lessons learned when someone else died.
Yep.
Or a bunch of people.
Or a bunch of people died. In the 1890s, there was an insurance company that was connected to a boiler manufacturer called the Hartford Steam Boiler Company. The Hartford Steam Boiler Company was the sister company of the Hartford Insurance Company, which is still around. The Hartford Insurance Company got damn tired of every time a steamship blew up on the Mississippi, which they did fairly frequently, they had to pay out. So what they did was they got all the insurance companies together and they established a testing company that would certify boilers, and now they certify everything, which was called Factory Mutual. It's now better known as FM. So anything that's FM approved came straight from the disasters with steam boilers. Came straight from the disasters with steam boilers in the 1800s.
And steam engineer certification out of the same system.
Yep.
So,
Unless you think that
We're done.
advances because people die. Outfit I worked for about 7 years ago, the guy who closed the circuit breaker and stood in front of it was a 1600 amp circuit breaker, and one of the three-phase fingers didn't touch all the way, created a jet of plasma, and blew him into fragments all over a room this size.
Electricity is fun.
So one of the things that Karen did at a previous Minicon was to hold a chocolate tasting of chocolate she'd made the way it would have been made at Cora's in Grantville. We can't duplicate that, but we've arranged for some Icelandic chocolate from Om Nom Chocolate to share in her memory. Please enjoy this in memory of Karen Evans, Rick Boatwright, and Kevin Evans. Thank you.